of this guy. So what are we going to get? Look at that, 28 dB. So we see that our parameters, GM and R out, are correct. The way we measure them are correct. So we see that we could extract the parameters from the box without even knowing what's in the box. That's very helpful. We try to evaluate this box. You can basically do the same thing with this technique, applying some input voltage and measuring the current in the output, or applying some output voltage when the input is constant, and again measuring the current in the output. I'm going to teach you one more thing. I'm going to teach you how to measure the capacitance also of any node in your circuit. So what's capacitance? If we just remember, refresh your memory for a second. So capacitance, we know, is we know that the impedance of a capacitor is 1 over j omega c. But when we measure some type of some impedance of any circuit, of let's say any box, or maybe we're measuring the input impedance. Right now I'm going to be measuring the input impedance of something. So we know that any impedance that we're really measuring is some type of V test over I test. And we know that that's going to give us the input impedance. But this is going to be some complex function of j omega, because this is not only resistors. It could be capacitors, it could be transistors, it could be inductors. So then it's not going to be some straight function. So this is going to change with the frequency. But also we know that this could be divided into two components. It could be divided into the real part and into the imaginary part of the impedance. And usually the capacitors and the inductors are part of the impedance part, where the resistors are part of the real part. But if we want to measure just a capacitor, and we know we have a box and it has some capacitance C, we don't know what it is. So let's say we don't want to use the model for the inductor. We just want to measure the capacitance. So we can just apply the imaginary function of the calculator in cadence to our ZT, and then we're just going to get the IM, and we know that would be equal to just 1 over omega c, because we have to take the j out. So we know that c could simply just be 1 over omega im, and we're going to measure im. We can't measure c. We're going to measure im, and then we're going to find c. So the trick here is really knowing how to measure right here. So we're going to be measuring the current going into the box, and that's might be either very, very large currents or very, very, very small currents. So don't be afraid, because usually the capacitance is very small, so the impedance is very big. So it makes sense that the current is very, very small. The way to do this is basically using the same technique that we've just done, is putting the circuit into some DC operation point, and then just measuring the input current instead of the output. And the output of the circuit should also be at some DC point. So either it's going to be floating, like in our open loop amplifier, or maybe you would have to apply some voltage or some load to put it into its correct operation point. And then we're just going to measure the input current. So let's do that in our circuit here. I'm going to basically use my GM test, and I'm going to be measuring the current going into IP. So if we look here, I want to also remember that I want to take the imaginary part of that current, and I'm going to divide it 1 over that. Just go back to the equation. So we're going to be looking at 1 over omega times the imaginary. So that would be the imaginary is just this. So I'm going to have to measure